Hello, this is Professor Gibson, and this is a video on Chapter 8, Section 1, testing the means, testing the difference between means. Okay, so in Chapter 7, we were testing claims about the mean. People would make claims that the mean is this or that, and then same thing about proportions. Well, in Chapter 8, Section 1 here, people are going to make claims about the difference between two different means. They're the same, one's bigger than the other, this kind of thing. All right, so we're literally going to be comparing two means. And in 8.1, like in the beginning of chapter 7, we're going to do it for situations where the standard deviations of the populations are known. All right, so this is called a two-sample hypothesis test because you're going to have two samples, one for each mean. We're going to compare, since we're comparing two parameters, in our case, at this point, in this section, we're comparing means, so the parameters are two means. We're going to assume that the samples are independent, all right? So independent means that the sample selected for one population is not related to the sample selected from the second population. It is possible to do dependent sample ones where they are related. It's another topic. It's a little bit more complicated. We're not going to do it. Here's an example of we're doing independent versus dependent. Classify each pair of samples as independent or dependent. Sample 1, triglyceride levels of 70 patients. Sample 2, triglyceride levels of the same 70 patients after using a triglyceride lowering drug for 6 months. Well, in this case, because it's the same 70 patients, right, it doesn't matter what's happened in between. These two are definitely related. Those are dependent. If there's the same people in both groups, right, it's dependent. Let's look at another one here. Classify each pair of samples as independent or dependent. Scores for 38 adult males on a psychological screening test for attention deficit hyperactivity disorder, that's sample 1. Scores for 50 adult females on a psychological screening test for attention deficit disorder, that's 2. All right, so it's not important here that the two groups are one's male and one's female. What's different is it's two separate groups, and the fact that it's a group of males and a group of females makes it clear these are two separate groups of people. Okay, so that would make it independent, and this is the kind of situation we're dealing with. It would have been, all we really need is 38 adults in one group, another group, and the two groups, right? They don't overlap. There's different people in both groups. That would be independent. Where one group's male and one group's female, it just makes it more obvious they're not the same people. All right, so what happens is it changes the way our hypothesis tests look a little bit. The hypothesis, not the tests. So one type of hypothesis will be mu1 equals mu2, and mu1 not equal to mu2, so that's the null and the alternative. Sometimes for this one, they'll write the null as mu1 minus mu2 equals 0. You see that's the same thing, right? You add mu2 to both sides, you get mu1 equals mu2. Anyway, another one will be that mu1 is in the null is less than or equal to mu2, right? First mean less than or equal to the second mean in the claim. And the third time it's greater than or equal to, right? So instead of having a mean related to 0, right? Mean equals 0, mean less than or equal to 0, mean greater than 0. You've got it to another mean, right? That's the change, okay? And then we make the same kinds of assumptions. We're going to assume every time we do this to start that mu1 equals mu2. It's the same thing as we were doing before. It's the nature of hypothesis testing. You have to make some sort of assumption to run the test. And so we're going to assume the equality part of the null hypothesis, just like we did before. All right, so what changes when we do this then, the two things that change are, one is the hypotheses, the structure of them a little bit changes, we just talked about. And the other one is the test statistic, okay? So let's move ahead a little bit. We'll get to the test statistic, and I will show you what that is. I'm going to do it in the context of showing you how to work an example, all right? So, using technology to perform a two-sample z-test, a travel agency claims that the average daily cost of meals and lodging for vacationing in Texas is less than the average daily cost in Virginia. I guess they're trying to get people to vacation in Texas instead of Virginia. Anyway, the table at the left shows the results of a random survey of vacationers in each state, while the table below does. Assume that the standard deviation of the population equals 20 for Texas and standard deviation 2 is 25 for Virginia. And that both populations are normally distributed at the alpha equals 0.01 level. Is there enough evidence to support the claim? Okay, so let's start with the hypothesis test. All right. They're claiming that in Texas, the one in Texas is less than the one in Virginia, right? Okay. So, and the Texas is the subscript ones. So the hypothesis then, right, is going to be that mean one, population mean one, is less than population mean two, right? It doesn't say less than or equal to, it says less than. So that's going to be the alternative. And that's the claim, right? And so then the null will be the complement, so that'll be greater than or equal to mean population mean one, population mean two. All right, so you see the way that it works really is the same as far as determining which one's the null and which one's the alternative. It's still the one without, if it doesn't have equality in it, it's the alternative, and if it does, it's the null. Okay? Now, the next thing that we're going to do, we will go ahead and do the p-value version for this one. Okay, we'll do the critical value or the rejection region for the next example. All right, so the next thing we need then is we're going to need to know, we can go ahead and do the test statistic. Let's note, so if we do the test statistic, let me show you something here. So this mess right here is actually what we've been calling the test statistic. Now formally, we haven't made a big deal of it. The book hasn't said anything about it. It's actually the standardized test statistic. It's the test statistic turned into either a normal value, that's a z, it's normal, or a t value. But now on some of the questions, they're going to ask you for the standardized test statistic. They'll mean this. Other times they make a comment, they want the test statistic as well. Well, that's what this is here, the mean of the first sample minus the mean of the second. You can tell which one is 1 and 2, just they'll number them for you in the question like they did here. I'm not sure why they ask it. We don't really use it for anything, but they do ask it. So I'm explaining it. All right, so we get our standardized test statistic. Now, you'll see this is a big mess here, right? This is a mess. So what I'm going to recommend, for those of you, if you have a TI calculator, either the 83 or the 84, they both do this, okay? What we're going to do, unfortunately, this is the one thing we do where the calculator is a lot easier than Excel. So in the calculator, you're going to do the following. You're going to hit your stats key. I recommend you write this down as we go along. Hit your stats key. You're going to arrow right to the arrow to the right twice. Pick the test menu. Okay. Then there's options below it, and you're going to pick to samp, short for sample, z test. Okay. And then you're going to put in the stuff that it lists for you. Now, so what's going to happen is you're going to see, we'll leave this slide here. You can come back and reference. I'm going to flip over to an image of the calculator and we'll do it. It asks you for the 2 standard deviations. Then it asks you for the first mean and then the first sample size, and then the second mean and then the second sample size. Okay. Then once you've done all that, you just click on calculate. All right. So let's see. We're going to do it. Okay. Actually, before we do this, what we need to do, let's go back up here and check what our numbers are. Oh, no, we can pull them right up here. All right, so we'll go back up here. We see what our numbers are. We'll see our numbers. Let's pull the calculator up. I'm going to slide it over here so it's not on top of the numbers. All right, so turn it on. All right, so let's do what I said. I'm going to hit stat. Let's try to turn it on again. All right, hit stat. Going to arrow to the right. You see test is highlighted. Then we want two sample z-test, two SAMP z-test. That's the third one. I just arrowed down twice and hit enter. Most of the time you're going to want stats. If they actually give you data points instead of all the means and stuff, you could pick data. But we're going to want stats. So we'll arrow over once to the right to highlight the stats. Click enter on that. All right, so the stats is highlighted. You see it changed what it asked for. So now it's going to ask for those two standard deviations. We can come over to the question. It told us the standard deviations were 20 and 25. So arrow down 1, 20. Arrow down again, 25. All right. X1, it says, is 245. I'm just reading these numbers right off the question. N1 is 25. Arrow down again, 25. Actually, if you hit enter, it'll bring it down too. X2, it says, is 251. And N2 is 20. All right. Arrow down again. And you have to pick, now you have to pick the alternative hypothesis. All right. Our alternative, if you look at it right up here, was less than. So I picked less than, hit enter. Move it over there, highlight it, and hit enter. Oh, actually, it lost it. Huh. All right, let's go back and get less than. I'm sorry, let's go back and get less than again. Calculate. Highlight, calculate, hit enter. Now you're going to notice with this, we had to do the first few steps the same, even though using this function. We had to pick our hypotheses, right? We had to figure out what the tail of the test was. Then we had to put our numbers in. Now, though, at this point, it's given us both z, the test statistic, and p, the p-value. Let's drag this over here, right? So our test statistic, it's all grayed out. Why is that doing that? All right, our test statistic now .873. So if they ask you for that in a question, you've got it. And our p-value is 0.191. Now we can finish the question from here, okay? If you remember, the question is about this claim in Texas, right? The claim that Texas is cheaper than vacationing in Texas is cheaper than vacationing in Virginia. It says use alpha equals 0.01. All right, so our p-value is 0.191. Our alpha is 0.01, right? So that gets us down here. Our p is quite a bit bigger than alpha. So we're going to fail to reject the null. Okay, so we failed to reject the null, right? Failed to reject the null. And then remember the claim up here, it matched the alternative, right? So since we failed to reject the null and the claim matches the alternative, there is enough evidence actually, so there is not enough evidence, right? To support the claim. Right? We didn't reject the null. If we'd rejected the null, then we could have picked the claim and we would have had enough evidence.